Next question. For the heterogeneous equilibrium system, so the system is calcium carbonate solid, calcium oxide solid, but carbon dioxide is gas. Here the physical state of the reactants and products in the system is not same, therefore it is referred to as heterogeneous equilibrium system. Delta H naught, the enthalpy change under standard conditions, can be determined from which one of the following plots. So we are indirectly asked to work out how this delta H naught can be worked out from the following plots between log E partial pressure of carbon dioxide plotted against 1 by T. Here also log E P of CO2 plotted against 1 by T. But in C and D, it is on the x-axis against T. So there is a change. It's not that these two are very similar. Similar when plotted against 1 by T and T. So the system here is CaCO3 solid, giving once again CaO solid. But carbon dioxide is the one which is a gas, for which we can write Kp. The equilibrium constant in terms of partial pressure is nothing but depends on partial pressure of carbon dioxide. So Kp is equal to P of CO2. And this enthalpy change in the reaction is involved by taking the relation similar to that of Arrhenius equation, K is equal to A into e to the power of minus delta H naught by RT. Instead of activation energy, we are putting enthalpy change, and taking logarithms on either side, we get log K to the base 10 is equal to log A to the base 10 minus delta H naught by 2.303 RT. This is the one which is relating equilibrium constant K in terms of enthalpy change with respect to temperature and Arrhenius factor A. So this K or Kp is nothing but now partial pressure of carbon dioxide. So log partial pressure of carbon dioxide to the base 10 is equal to log of A minus delta H naught by 2.303 R into 1 by T. Of course, it can also be written with respect to ln P of CO2, that is base E is equal to ln A minus delta H naught by the 2.303 we remove, thereby can be written as R into 1 by T. And this equation is very similar to y is equal to some constant ln A, that is C, plus m, where m is the slope and x is the variable. Y is equal to C plus mx, where m is the slope. So comparing to this general equation, we have slope m from the above equation is minus delta H naught by R. So it is negative value. So thereby, what is y is equal to mx plus the graph with negative slope. So that comes out to be, this is the one with the negative slope. Here also you can see log base E P of CO2 is plotted against 1 by T. So therefore, we get a straight line with a slope of minus delta H naught by R. This being negative slope, A is the right answer. This corresponds to positive slope, wrong. And here it is plotted against T instead of 1 by T. Therefore, this as well as this are wrong options. So A is the answer.